First, I show you the Kaguya mission objectives. The primary objective of the Kaguya is the lunar science. So that is a global survey of the moon to study the origin and evolution of the moon by observing the elements and also minerals on the surface, and also the surface structure and subsurface structure and gravity field, magnetic field, everything. So that is the primary objective, and also these data are used for the future moon utilization activities. That is the second objective. And third one is the technology development for the next step lunar exploration. And also the public outreach is very important for us. And for Kaguya, we'll take the movies of the beautiful Earth and also the beautiful lunar surface. Okay, here is the Kaguya configuration. So the Kaguya consists of the three spacecrafts. Main satellite in the center of the picture, there's a main satellite, and also we have the daughter satellites, two satellites over there. So we have three satellites. And the external view of the main satellite, you can see the solar paddle that generates 3.5 kilowatts power. And also you can see the dish over there, that is a high gain antenna. So the data is transmitted to the ground very high speed, 10 megabps. And also the mission instrument, there is a mast, 12-meter mast. That one, that is used for the magnetometer. And also we have the antenna, 50 meters antenna extended from the main body. That is used for the radar sounder experiment. Right-hand side, the Kaguya, the size, the weight is almost 3 tons. That is very heavy for us. And the size dimension about 2 meter, 5 meters. So that is a large satellite. And the orbit is the 100 kilometer altitude, and the inclination 90 degrees. That is a polar orbit to observe the global map, to make a global mapping of the moon. And we have daughter satellites that is named. They are named Okina and Ona. That is all the traditional Japanese names. And that they are very small satellites. That they are 50 kilograms, and the size is just 1 meter scale. So they are very small. And the orbit is 100 kilometers by 2,400 kilometers. That is the elliptical orbit. That is one Okina satellite. And for the Ona, Vista, that is the 100 by 800 kilometer elliptical. Anyway, these two sub-satellites are used to study the gravity field of the moon. And this slide shows the configuration of the onboard instruments. The blue ones are the mission instruments or scientific instruments, and others are the bus subsystems. So after the launch, that was the September the 14th, we had phasing orbit like this twice around the Earth, and then we reached the lunar orbit. It took 14 days to get there, and here is the lunar orbit insertion, the LOI. That is the most critical operation in our operation. And first we had the elliptical orbit. So the apogee was lowered by the orbit maneuvering operation several times. And finally we got the circular orbit, mission orbit, and the inclination 90 degrees. And during the orbit transition, we separated the two sub-satellites. And immediately after reaching the mission orbit, we extended the mast for the magnetometer and also extended the 4 antennas. Okay, in this case, we are flying over the North Pole. of the moon. So here the Earth, and in this case the wide angle camera is used. So actually this Earth is smaller than the previous one. So in this case the north is this side of the Earth, and you can see the typical crater here. This is 100-kilometer size. Now usually the 100-kilometer size crater has a central peak, or the exact name is I don't know, but there is a peak inside the crater that is generated by the impact. That is a very typical one. Anyway, we can see this kind of a very clear image. In this case, we are flying over the Sea of Serenity. That is located in the northeast portion of the moon. So in this case, the playback speed is 8 times, so you can enjoy the flying over the moon. Just a demonstration.